Okay, so I think we can start because whoever had the train and had to run for the train already did, right? Can you see the screen? Can you turn off the lights so that it actually is visible? The lights on the front? No? Oh, already in progress, okay. So, welcome everyone to the last talk. I know you're tired because after 3 days of heavy drinking, or I mean the conference, what else could you be, right? I'm also tired, so let's do this. We're gonna play a little game. The game goes like this. Our goal is to inflict as much damage to the project and the system and the company and the people as possible, okay? But we cannot get fired right away, because if you get fired, you cannot inflict any more damage. So the goal is to inflict damage by making bad decisions, but they have to look good, okay? If you get promoted by making those decisions, then it's even better, right? We are going to call this insane highest DPS, right? So this is our build. This is how we're gonna do it. So first thing we can do, let's say that we have a system on production. It's already there, right? People working with this, and you have a bug. What's the worst thing you can do when you have a bug in production? It impacts the customers, the company loses money. Basically, it's a bad situation to be in, and it's a situation every one of us actually was in, right? What? Wrap it as a feature. That would be cool, right? No, actually, the worst possible option that we can have is to fix it, and to rush to fix it right away. Why is it so? Well, first of all, it's a natural thing. It looks good, right? We are losing money. The customer is angry. So there's no time to waste. Let's put some pressure on people. Even better it is when you actually decide to, well, let's have all hands on board because it's a difficult situation, and let everyone fix it, right? So everyone who has an idea, implement the fix, put it into production. Let's have all those fixes there. It's gonna be great. Now, why is it so bad, right? For several reasons. First of all, well, people are stressed, and this is urgent, so we have to do it, right? We are losing money. When people are urgent or stressed, they basically make a lot of mistakes, so we're gonna have a lot of bugs in our fixes, which is great. Then, when we have that, the first idea that you're gonna have about what's wrong is actually going to be most likely wrong. So, the first idea won't work, but we have it on production with the bug in it, right? So then second idea and the second fix will actually have to fight with the first fix, with the original bug and the bug in the first fix. And if you have several people doing this, it's going to be even greater because, well, now you have several bugs. You used to have one, now you have several, it's great. There is even a name for this kind of strategy, and I've seen, like, most of the companies I actually know use that strategy, right? It's called shotgun debugging. And it works by providing a lot of different fixes in a hope that something will work, right? Okay, so what's the correct approach to this problem? Because this is horrible, this is slow, and we are actually making the situation even worse. Well, the best idea is to actually get everyone together, form hypotheses, and then not fix it. Instead, write them down. And write even the stupid ones down, because, well, it might be true that the stupid one is the correct one. Then, when you have the list out there, for each of them, create a verification plan. So basically, answer the question, how are we going to verify this? Whether this hypothesis is correct or not. And remember that rejecting a hypothesis is much easier, usually, than confirming it, right? So you don't have to provide a fix. Just confirm that it's not that one. And so when you have those, then you have to cluster them, because there's many of them, right? I usually do it this way, that if it's something is going to take me a few minutes to check, let's put it in the A cluster, and if it's a long solution which require an hour or so to actually implement, it's a B, then verify all those A's, and we are left only with the B's, right? After you are only left with one, or maybe just a few, because they take longer to verify, then we can try to fix them and basically provide that verification. And if you verify it, and this is the problem, now we go to production, right? Now, the benefits of this method, and this is a scientific method, by the way, this is how research is being done, is that, first of all, it's going to be much faster, even though it doesn't look like. And the reason is because you're doing breadth-first search instead of just implementing random stuff and wishing for the best. Then it doesn't introduce as many changes and no new bugs in the system, hopefully. And then you will understand your system much better, and this is great. So to do that, we have to solve two problems. The first one is that to be able to do so, we have to have data to form hypotheses, right? And then your arrogance is your enemy. So let's try out what kind of bad things with a large damage we can do in there. So first of all, to make it hard to form a hypothesis, what we can do? Not provide developers with an access to information, right? And the best way to do it is to separate them from the production system, right? So we're going to say, due to the security, you cannot actually touch the production system. Instead, you have those pipelines that you can use to deploy a new version to the production, right? And a lot of companies actually do this. So what happens now is that every single verification of an idea, so you want to confirm or deny the idea, right, so the hypothesis, will require you running the pipeline, which sometimes takes 5 minutes, sometimes takes 15 minutes, right? Which is great, because it's going to be dead slow. And then, also, each of those deployments actually impacts the production, which means you can break the production even more, and you impact the customers, so basically it's great. Okay, what about if the developers are very smart, these are senior people, right? And they want to do some debugging because they see that it's going to take forever for them to do actually this kind of approach where they just deploy to production. Well, we can help them by not helping them when we make it very difficult to actually debug on production by providing them, for example, with a restricted virtual host. And what do you mean by restricted? Well, first of all, it's got to be very, very slow, right? Like dead slow, like you move the mouse, nothing happens for 5 minutes. Then, it also has got to run Windows and no other tools, right? Yeah, because, you know, because of reasons, and the reasons are security, right? We have to control the access to production. And then when we have all of this, it actually sounds like a very good idea for a product, right? Let's sell this thing. We're going to make a lot of money. Let's throw a random name from the internet, something like this, for example. And voila, we have it. Okay, so what are the correct ways to do it, right? First of all, you can do something like telepresence, which is a tool for Kubernetes, which works in a very smart way. Because what it does is it deploys to production a pod, so basically a version of your application, which doesn't do much except for being a reverse proxy and actually connecting to your local machine. And then you run your software on your local machine and basically reply to all the requests from the production environment. So you're being able to restart the service and redeploy the service, modify it. You don't have to go through the pipeline. So the feedback is very, very fast, right? So that's much better. But there are problems with it. And the problems is, of course, security, because now you have a reverse proxy to your local host, right? So security is crazy about that. And the other one is, well, you're eating the events from the production. You're responding to real requests, right? That sounds great until you hit actually a user this way. So maybe that's not the best way to do it, although I have to say it works, right? From the perspective of a developer, good feedback cycle, right? So what's the correct way to do it? What if we had all the information in the logs? That would be beautiful. That's what they are for, right? But we could, look at the logs, see what's going on, replicate the bug on local environment, start the application, or maybe just run an integration or unit test, and be happy with it, and be able to confirm or basically reject the hypothesis or even the implementation, right? And that requires two things. First of all, it requires good logging practices, and then it requires software working on localhost, right? That's easy to do. we have the tools right now, like test containers, where you can set up a lot of different Docker containers that run together with your integration test or your application in a local environment, and be able to, replay whatever happens on the production. And that's great, except people don't use it. And when you have a bug, what happens is that people say, yeah, that would be great if we had like a working software on localhost, but I don't have a local profile on my application because, we didn't have time to do it, and now we have to fix the problem, right? Fix the bug. So instead of actually setting all this local profile up, I'm gonna just try to fix the bug, right? And this is what you have to understand, that this is madness, and basically you have to say no. So I have seen companies that in their documents, like the mission statement and so on, they say that they cherish hard work. You should not cherish hard work. Hard work should be prohibited, okay? Work should be easy. If it's not easy, then what you should do is spend 75% of the time to actually make it easy, and then spend the rest 5% of the time to solve the easy problem, right? And it works every single time. So if you don't have a local environment, it's better to actually spend half an hour or an hour to set it all up, and then verify what kind of problem do you have on production, okay? So now we know that we can do it, but fortunately, that's not everything. We also have logs. And to have logs, you have to have somebody writing those logs. And most of the developers actually do not write any logs until they need them. So it's a little bit too late, right? If they do, they have a lot of bad practices. Like, for example, this one. What's wrong with this log? First of all, there is no information whatsoever provided, right? You don't know, when you see this in your logs, basically you don't know what is being whitelisted or why, right? You only have this and perhaps the trace ID or maybe the thread name, and that's it. Second, it floods the log because it happens every single time. So basically, if you have a lot of good operations, then you're gonna fill the log very easily, right? And then third, the best part is that even if you have it, you will know nothing because you will not know what happens or why when the if statement is incorrect, the condition is incorrect, right? So a better way to do it would be actually to put the log on the other side. Say, you know what? It should be there, but it's not there. And I've made a decision that I'm going to ignore it because nothing happens from now on. This method doesn't return anything and doesn't do anything. The only way to understand what's going on in production is to say, I'm not doing anything because of that. So that will be a little bit better. But then there's another practice, okay? And that practice is this. Let's have a look at this piece of code. So we have a little bit longer business logic there. And now the developers put logs every second line because they've learned on production that they cannot see anything if they don't have logs, right? So that's great because we are actually obfuscating the original code with all the log information, and this log information will fill up our log aggregation mechanism, whatever we have, and then it will provide a lot of useless data for the user or for the developer, right? And then again, we don't know if that map will actually not work, right? So people who use maps or basically functional programming quite often forget that it's important when you don't do anything because it's an important information there. So a bit better would be just to, I don't know, throw an exception because it's Java, or maybe something local, like for example, add a log there, like we all do, right? That would be a bit better. But what would be a good logging practices? First of all, log on each code branch, right? Log on each external call, because especially if it's synchronous call, like a REST call, because you don't know if you're going to get an answer back, and you'll be able to log anything else, right? Use a higher order function to remove all the clutter from your logs. What do I mean by that? A very simple thing. The previous code could be written like this, when the first 2 lines up there is actually higher order function. When you do, basically you wrap up all the defensive programming there, or in this case, offensive programming actually, And so you have those two methods that will basically do the logging in case of an emergency, and you will know what's going on. And apart from that, you have a method with a simple code that actually works and tells you what it does, right? And if you have logs on the positive side when you're further away, or basically you don't have to put a log on every second line if there is no code branch possible. So there's no branching there, there is no ifs, anything, right? Okay, and then another good practice would be to actually use the mapped diagnostic context, which is the part where you can actually say, you know what, I got an event or I got a request, and for this request, this is the important information which should be in every single line of log when you're looking at it, right? And it's very simple. You just use the MDC and you put something there and you clean it afterwards. And you should do it on every event listener, scheduler, controller if you're using no reactive programming, at least, because in reactive programming you're going to switch a lot of different threads, and this is per thread, right? Now, my hint for you is different. I do test-driven development, and you do as well, because if you are not doing test-driven development in 2022, you are paruwa, as we say in Polish, or you are in a stone age, as you say in English, right? So that means that when I do test-driven development, I see a lot of bugs. And in test-driven development, it's very easy to just press a breakpoint and see what's going on, right? What's inside this data. But I've learned that because in production, I will not have that chance, maybe the better way would be to actually look at the logs of my application. And the logs of the application inside the test are usually garbage. Because, you know, all those frameworks, all those libraries, they all log. So you have to clean it up. And if you have this log, and this is a real business log from a test, right? And it tells you the whole story, then, if this is everything you need to be able to fix the test, the red test, then there's a good chance you will be able to fix the problem on production as well, okay? So now what else can we do when we want to do damage? Well, for example, we can mess up log aggregation. How so? Imagine we are developing a new log aggregation mechanism. And basically, we will do something like this. We will create a mini when you will be able to look at different information, right? So most of the time, developers will either want to see for problems. So we will make this label exceptions there. And other times, they will want to look like all the logs to be able to investigate. So we will create traces. Okay? But here's the evil thing we can do. When we say log error, and we don't have an exception there, we're going to put that into traces, not exceptions, because we don't have an exception, right? But if the developer actually provides an exception as a second parameter, we're going to put that into exceptions, but not traces, because why not? It's an exception, right? And so, when you do this, what happens is that if you click on logs, if you click on traces in UI, you will never be able to see any problems because there'll be no exceptions except for log errors without exception. And if you look at the exceptions, you will never be able to see all the problems because you will only see exceptions without log error, without error exception, right? So that sounds good. What if they have a query language and they can ask for the information, do something like this, when they say traces, union exceptions, and they want to join both of those things because at the end of the day, they want to find all the problems with the production? Well, we have a solution for that. What we can do is we can put the name where we keep the message, the field name, and make it a different one for each of them. So in the case of traces, we will have a message in the message field, but in the case of exceptions, it will be the outer message field. So it's going to be very hard to actually analyze them all. Sounds like a good idea? So how long till they find it out that they are not seeing all the errors? What do you think? Now, I tested that. 4 years. Not bad, right? And fortunately, you know, writing a new log aggregation system, that's going to be like a lot of work. I don't know if it's worth there. But fortunately, there is a tool there we can buy and actually use. And it works exactly this way. And it's called Microsoft Azure Application Insights. So that's great. Now, even the aggregation we can have completely wrong, right? What else can we do? Well, as I said, apart from logging, there is another problem with actually using this scientific approach, which is your arrogance. And here I have a personal story, okay? So something like 10 years ago, I actually, I played volleyball like once a week, and at some point in the time, my legs, or actually my knees, started to hurt a lot. And I wasn't able to play anymore. I wasn't able to even walk anymore. That's the point when I actually went to see a doctor, because why would you do it in a different way than when it's already too late, right? So, and here's the problem. Doctors, just like IT developers, like senior developers, are very arrogant, okay? They think that they know what the problem is. And so the doctor that I went to, he looked at my knees, basically. He asked me some questions, and he said this: "You're not going to play any sports anymore. Your knees are completely destroyed. You can't do anything about it. You put too much pressure on your knees. It's over." And I was devastated, because like at that time I played volleyball for like 20 years, right? And so I said, well, I was completely shocked. I asked him, can I swim or do other sports, right? And he said, no, the knees are gone, you can't do anything. Just lie there and die. Next patient, please. Yeah, so I didn't like that diagnosis, right? So I decided that, maybe I should see a second opinion and a second doctor. But the problem was really that what was the incentive for this doctor, and why was he so arrogant there, right? And I think I know the answer. This was a private doctor, so private medical examination when actually I pay for this, and he's getting paid per visit. That means that whenever somebody visits him, it's important for him to get rid of that patient as soon as possible and get another one, right? If he's correct 80% of the time, then it still makes him much more money than if if he would be correct 99% of the time, but it would take much more time to actually fix those things, right? So he's got no incentive to do any kind of debugging, right? He just looked at my knees like a Superman with X-ray, right? And that's it. So maybe I should look for a doctor who actually would do some kind of debugging, and basically would use the tools that medicine has these days. So I went to a second doctor, and this time, how do I find a doctor that would actually want to do some debugging, do some research? Well, it's very hard to find such doctors, so I decided to go to the Sports Center of Medicine in Warsaw, because I thought, well, these guys are actually helping the real athletes, professional athletes, and their goal is actually to bring them back on the playground, right? And not just to say, yeah, you're completely destroyed, that's over, bye-bye. And so I did that. And the interesting thing was, there was a huge difference between those two. This doctor actually didn't ask me a thing. He said, do you have pictures of my knees? No, but I can take you one right now. No. Give me an X-ray and give me another one from the machine that goes bzzzt, right? I don't know what it is, but basically with all those pictures, and it took like 30 minutes actually to get them. It's very, very easy, right? After that, he looked at those pictures, he looked at my knee, he asked me a lot of questions, and then he said, your knees are completely fine, but you are putting too much pressure on them, because you don't have enough muscles to protect your knees against what's happening, right? So what that means is you have to train more, at least 3 times a week, okay? And also have a longer warm-up, right? That was a better diagnosis. I like that much more, right? So which one was right? I'll let you decide. The next 10 years, I won more tournaments than in 20 years before. In 2019, right, so before the COVID, I actually played in 15 different tournaments and 2 leagues. And I won most of the tournaments. And by winning, I'm saying I got first, second, or third place, because actually, for me, winning is when I have a medal back there, and that's it, okay? So, who was right? What do you think? That's not a rhetorical question. Could be both? Neither of them. That's the interesting part. Because for some time I thought, yeah, I like the second one. That's a much better answer, right? So, and I got the outcomes. Turns out that wasn't correct. And I found out only after 8 years later when I found a third doctor that was more like into debugging than anyone else. Because, yeah, so because that doctor actually looked at the whole situation. Actually, there were two of them, and the story goes like this. One of them was looking at my knees, and he said, "Oh, kurwa." And he said, he had another one, and he said, John, come over here. The other one came there and said, "Oh, kurwa." And so the first one said, "Have you ever seen anything like this?" No. And so they did a lot of debugging because at least it was interesting for them, right? And it turned out that if you play, by that time I had like about 28 years of experience in volleyball, playing volleyball, right? And it turns out that if you do the same exercises over and over again for 28 years, your body bends in different ways. And the athletes these days, what they do when they train anything, they actually do compensating exercises to not push the body too much into one direction. I didn't know that, okay? I'm so old that back in my days, they didn't tell us this, right? And so my legs are completely wrong for a lot of different reasons. That was the kurwa. But the solution to all this problem was actually, if you understand the reason why you feel pain, then what you should do is train more, but do the compensating exercises, right? So, and now it's too late, I already won all those tournaments, so I don't know. So don't be, by all of this, I mean, don't be the first or the second doctor. Don't try to, just get over with the ticket. Don't try to find a fix which will fix and you will not understand where the pain comes from. Be the third doctor. Do the research and basically find the reason. You will be much brighter by understanding what's going on underneath, and the client will be much happier because, it's going to actually solve the problem, right? Okay, so we've done a lot of damage to the system. Let's do some damage to people, right? So, what's the best advice you can give to somebody who comes over to you, or maybe it's you, and they have all the symptoms of a burnout? So basically they feel like, I feel like shit, I don't know, the project is all fine, but I have hit really hard time to get up in the morning and go to work, right? Maybe I should, I don't know, drop all of this and just, do something like sell hot dogs on the street or something? Get a grip. What are the other options? Something that would sound like a good advice, but wouldn't be. Drink more. That's a very Polish version. All right. Relax. Okay. It's a kind of a nasty thing to say to somebody who's all stressed up. Relax. So what else can we do? How about take 3 months off, go for a holiday, relax. Yeah, relax. And then come back to work. Would that work? That sounds good? So this is actually a great example of how we can apply maximum damage to that person. How so? Well, first of all, we are not addressing any real problems, right? We don't know why you feel bad. I have no idea why you feel bad. And also, we are not solving anything. We are not even trying to, do the shotgun debugging by just trying to fix. We are just saying, you feel pain, go there for vacation, take 3 months off, rebuild your stamina, and basically come back and feel the pain again. It's gonna rise, right? So that person is going to feel the pain longer. That's why it's so evil, right? And the thing is, again, just as with the hard work, some people think that the job should be painful, right? It's hard and it's painful, and that's what we like, right? You shouldn't like that. You should run away from this. But how do we run away? If you change the job, by the way, right away, it's also wrong. And to understand what we should do, this is what we will do to maximize the damage. But what should we do if it hits us, if we don't want to be in pain, and basically we want to fix this, right? Well, to answer that question, we have to understand a little bit about the brain and the USA. So, let's start with lobotomy. Now, lobotomy was invented in 1935, and that was a Portuguese medic who actually came up with the idea. And then a bunch of US actually neurosurgeon James Watts and neurologist Walter Freeman actually decided this is a very good idea, because you can do a lot of good things with it if you basically delete a part of brain from a human being, right? For example, if somebody has got a seizure, you can do that and they'll be quiet. If you have kids who run a lot and scream a lot, you can do that to them and they'll be quiet. And the other neurologist from the USA said, this is the most stupid idea we ever heard. But the media said, it works, the kids are quiet. And so 40,000 of US families basically decided, yeah, let's do that to our children. This is a great idea, right? So USA is a strange country. So now, knowing that, it will be not a surprise when we will find out that there are other operations on the brain which the US population likes a lot. For example, there is this one when you cut the connection between both halves of the brain, right? And you may need to do it. Sometimes it's necessary. The two situations when it's necessary, or sounds like necessary, is first of all, you have a hole inside one half of the brain. For example, due to an accident. Now, the hole is a problem, but the problem is you can save the other half of the brain. So how about we just cut it there, take it out, and leave the person with half of the brain. The other issue that you can solve this way is when you have epileptic seizure, which on the electrical level looks like, you know, the feedback loop of electric mechanism. Basically, the electricity goes from left to right and goes like crazy, right? So if you cut it in half, there'll be nowhere to go. So that means you will not have a problem, that problem anymore, right? And so we have a lot of people in the US and around the world, basically, who were actually have only half of the brain. And the research is interesting because the research shows two different things. First of all, it shows that when you do this at a very young age, that individual will actually develop okay with only half of the brain. There'll be no difference, no significant difference in the IQ, for example, which is crazy, like we only have half of the brain, right? Well, looks like our brains, our minds are a piece of software that can run on any hardware available. And that's correct, because what you can, the other thing you can do actually, is they took a mouse and basically disconnected the eyes and also, I think, either the smell or the hearing, and reconnected them, rewired them to the different parts of the brain. Basically, they switched the sight with the hearing, right? And the interesting thing, after about 2 weeks, the mouse is completely fine. It sees everything, and it hears everything. The brain, the software, can remodify itself to run on any hardware available and interpret any kind of a signal that you send to it, which is incredible. So, the brain is software, the mind is software, right? And the brain is actually the hardware underneath. The interesting thing is also that when they actually tried to check on those people who have those two halves of the brain, but disconnected due to the seizure, the left part of the brain, or the left cortex, is actually controlling your right hand, and the right one is controlling your left hand because wiring, I have no idea. And they actually did a lot of research on like showing pictures or showing things and asking that person to choose something with both hands, okay? Whether they like a picture or they do not like a picture, whether they like the object or they do not like the object. And the interesting thing is, there is no connection between those two parts of the brain, and those two parts of the brain choose different things. They have different personalities. They prefer different things. They want to do different things. So that suggests that we have actually two different people inside your brain. And it's even worse than that. But before we go further, let's make one thing clear. Your consciousness is not the thing that makes decisions. That's another tricky part to understand when we want to solve the problem of a burnout. Your consciousness actually only narrates the decision. And the research, there is like a lot of different research there that shows exactly this. This one is actually this exercise actually looks like this, where they make the person choose an option based on some, exercise, and they are choosing either left or right. And they monitor which parts of the brain actually, where all those things happen inside the brain. Then they put this little machine that goes brrrt and puts a little bit of an electric impulse into your brain so that you actually make that decision whether you like it or not, because we are simulating, or from external stimuli, we are simulating the same thing as what happens when you actually make a decision. So this is an enforced decision. And the interesting thing is, your consciousness will always think this is your decision. No matter whether this was actually yours, like inside your body, or it was due to the machine. And there is more research on that, and it's really interesting thing to read, because it turns out that all the decisions in your head are made before your conscious self realizes that. And it suggests that the consciousness is only a narrator. Basically, it builds a story for you. What is it for then? We'll see about that. And so, you do not make any decisions. Those decisions are made by all the unconscious parts of your brain, and then you only are informed, and you build a story, like a bullshit story around it, right? Oh yeah, I choose that because, it was the best choice, right? So that's how it works. And then there are people who have dissociative identity disorder, which is this kind of a problem where you have, you are being taken over by different personalities. So like you think you have 12 people, up to 12 people usually, in your head, and they control your body and basically your voice from time to time, and they rotate, right? So this kind of a situation is interesting because it shows that you don't have to have two halves of the brain and two personalities, but maybe you have just a bunch of different personalities inside your brain, and you just don't know about them, because you have this part, which is the conscious mind, where you actually try to narrate as if you were a single person, right? So that's actually real. So is it only for the sick people, the people that we say, yeah, we know about their many personalities just because they don't control them? Or do we all have those many personalities, but we have a conscious mind just to explain to us and put some integrity in there, right? So here's the hypothesis there. The weak hypothesis is, we have at least two personalities in our head, right? Splitting the brain gives us two different people. Human software can run on limited hardware and on any hardware in particular, right? Decisions are made before the conscious voice knows them, and you can have many personalities inside a single brain. So the hypothesis is, you have a team in your head. And your conscious voice is just trying to negotiate some common, understanding of facts, what we do together, right? Okay, so knowing all of this, how can we address the source of pain when we feel like a burnout, right? So I asked actually because like I've worked for, the last 4 years I worked for a company called Vattenfall on a very nice project, which was to move a monolithic application into microservices and basically build the whole system around it, and we did it. And it took us about 2 years to get rid of the old system, or basically for my team to never touch the old system, because when you use the one of the patterns, which is called the strangler pattern, the old system actually still stays there for a long time. But you don't have to touch it anymore, and basically nobody cares. So we did it after 2 years. Then I spent the third year just watching the system and trying to learn my mistakes, or basically whether I made any architectural mistakes out of that by just, supporting the system that I've built, which is the thing I've done most of my life, right? And then the fourth year came, and I started to feel real bad. And I was like, what's going on? And I was trying to find out, with my conscious mind, trying to think about, is the money okay? Well, it's great. Are people fine? They are wonderful. Am I stressed? Well, I'm stressed due to the war and the pandemic, but not due to work. The work, actually, I've never worked in a company which was so relaxed, right? They have like a nuclear power plants, and they are relaxed. And so what's the problem? do I want to work with different technologies? I have the total freedom. I can choose whatever I like. So it looks like the perfect situation for a developer and an architect to be in. So what's wrong? And I was like, yeah, that's some kind of feeling bullshit, I don't know. And so I called my sister, who is a working psychologist, and she said, and she actually treats these people who have either a burnout or a depression. And depression is kind of a different because it can come from, for example, chemical things happening inside your body. But the burnout is she usually starts with asking for emotions. And she says, usually what happens is we try to find an emotion which was suppressed. And when you do it, then you might understand that, part of my body or part of my brain, one of the personalities in my brain, if there is an emotion, then it raises a red flag and says, okay, I don't like this. And the other 11 different personalities in my brain say, we don't care, we have fun, it's nice, right? But that personality says, I don't like this, and puts a red flag over and over again. And after half a year, it can say, fuck that, I'm not going to work with you anymore, guys, you're real assholes, and takes a handbrake and says, stop. And that's where you have burnout, right? That sounds okay, so what should I do? And she said, you need to listen to your feelings. And that didn't work well with me, because, what am I, a Scala developer? Hey, I am an IT guy, right? I don't have feelings. Oh, I do have feelings. I'm hungry from time to time, right? But that's about it. I don't like feelings. In fact, when I think about myself, I prize myself with the fact that feelings do not, my emotions do not control my behavior. At least that's what I would like it to have. Instead, I would like to control my behavior with my conscious mind. That's what I like. So what kind of feelings are we talking about? And it was very, very difficult for me to understand what to search for and basically how to find those feelings, right? But then she gave me this. And she said, this is a table that I do with, people that I help come out from this situation. And basically, there are only 5 different feelings. And you can feel joy, but then you don't need to, you don't have a problem, really. You can feel a fear. What are you afraid of? And I couldn't find any fear in me. So you can feel frustration. Okay, so what do we do with the frustration? Need to find a new strategy. Yeah, but for what? Like, ask for another type of task at work. I decide what I do at work. So maybe it's not frustration. What else could it be? Anger. My boundaries are being crossed. Well, it's kind of hard these days to cross my boundaries. So, not really. And then sadness. Sadness? What do you mean? And let's have a look at this. Need to figure out how to find it in my life, okay? Missing connection, talk to somebody. Open up in my friendships. Or find new friendships. Reconnect with your hobbies, activities that are available for you. Okay, so I can do that. So I've checked, and I basically looked at different things that I do. And I spent about 75% of my time for the last 4 years actually developing the system that I talked about. But I also looked at the other 25% of my time, which is when I do workshops, or I help other companies. Like, for example, they have a problem with microservices. They say have 100 of them, and none of them are in production. So, and they want to go to production, and it's going to blow up, right? So they call me, and I kind of help them. Or they want to, it's earlier in the phase when they want to design those microservices, and so on, so on. And I looked at all the things that I do to search for those things which I really like, and something which I do not do right now, that brings me sadness. And I found out that I'm an architect. I design things, and I have nothing to design anymore. Why? Because after 3 years, the system was running, and it's a daily job of writing a new feature, adding that feature here and there. It's nothing really to design. Like, it's so easy and so small that my brain, or that one personality out of 12, thinks it's boring. I don't want to do it. And a handbrake, right? So, what can we do with that? Okay, I left the job. So basically I worked till the end of this month because it's a current situation. I left the job right away and I felt, much better for this. But I thought, okay, all that situation with the burnout, kind of feeling bad, is me not looking at emotions. How do you look at those emotions? How do you monitor your system, your 12 different people inside your brain? What can you do? And so it turns out that my girlfriend actually does a lot of good things that I can learn from her. So for example, she does this. She goes and spends, a weekend in a forest or somewhere, or in the mountains, wherever else, and she listens to herself. This is monitoring. Okay, I thought this was bullshit, but now I understand. Then she writes daily journal, writes down emotions, what she felt that day. And I also thought like, wow, this is such a waste of time. But it turns out this is logging. You have logs of what happened to you, how you felt, right? All 12 of you, not only one. And then she does meditation. And meditation is another, new age, bumbo jumbo, whatever. But it's garbage collection. Yeah, you have to clean up your logs, you have to clean up your emotions, all the urgent ones, so you can dig deeper into the emotions that you have underneath, or basically get rid of the emotions from the most angry person and basically look at the 11 other people in your head and find out what emotions do they have. So it's important. And then the one that I actually do understand because it comes from me, which is fishing or drinking with friends. Getting drunk. What is it? That's probing the system. Yeah, because we get together and we are like, yeah, my love sucks. No, my love sucks more. See what I did last time. This is horrible. My job, my career is going nowhere. My wife is going to left me. My kids are horrible, and so on and so on. You're probing basically and looking at it and trying to find out, is this a correct behavior or the situation that I'm in? Well, everybody else has got the same situation. Okay, that's okay then. Let's see what happens with another one, right? And you're trying to compare yourself with other people that you know and you love to find out whether your system, the way your system behaves, is actually a bug or a feature. Okay? So here's how we debug the brain. You can use those for example. And there's a lot more things that we can actually use, but usually there are in like newspapers for ladies, which I am kind of afraid to touch, and they have all those good advices into how you monitor your system, basically, right? So if I can recommend something for you, is to have a book. These are two great books that are very easy to read because they were written very well, and they will explain all of that in a very nice manner. And that will be The Brain, The Story of You by David Eagleman, and Behave, The Biology of Human at Our Best and Worst, and by Sapolsky. And if you don't like reading books, the second one is actually available online as a video lectures from the author, giving lectures to the students at some university in the USA. So you can watch that. It takes about 24 hours, I know, because I actually watched all of that and then I bought the book. But it's good, it's really interesting. So this is how you can be better at logging, debugging, and fixing things, or you can be worse and do the maximum damage that you think about. Thank you. Any questions? I don't have that link, though. Slido. Sleek. What? This? Okay, so 2022, right? And we should actually show that, right? Somewhere here. Okay, did you let the doctor leave? Yes, because I forgot about his name. That's the problem. Unfortunately, it happened 10 years ago, then, you know, I've learned, right? Did you consider getting instead of going through your emotions? No, because I thought that this is not important, and basically, you know, emotions, I can get rid of them within myself by just, you know, maybe drinking more, I don't know. Isn't drinking more like chaos engineering? Yes, I think actually this is the best description of drinking process, yes, especially if you're doing this in the city center. Yeah. Any more questions? Then thank you very much. See you next year.